It's my last day of quarantine and I was planning on going through all of this in class with you guys, but we're going to go over it now and we can go over any questions when I return. So we've already finished the first 2 pages and then a little bit more on this handout, and everything prior to this point right here, this is all chapter 10. Okay, so it's all chapter 10. Everything here is going to be chapter 12. So chapter 10 again is looking at moles, molar volume, the number of particles, and this chapter is dealing with converting from grams to moles to grams. So here's the central concept right here: grams, moles, moles to grams. So the next problem on the test, problem number 5, is going to be dealing with the molar ratio. And it's going to be referring to, the next few questions are going to be referring to this equation right here. Magnesium reacts with hydrochloric acid. This is what we've done many times. This is what produced the hydrogen gas for the giant Pringles can explosion. And we have 1 mole of magnesium with 2 moles of hydrochloric acid produces magnesium chloride and hydrogen gas. So we're looking at the molar ratio. Molar ratios are going to be comparing moles to moles. So we're going to be looking at starting with the number of moles of reactant, converting it to the number of moles of product. So determine the moles of product if given the moles of reactant. So let's try to determine, for example, what's the number of moles of hydrogen gas produced. So the number of moles of hydrogen gas produced. So this is the product. And let's say that we start off with 1.4 moles of hydrochloric acid. 1.4 moles of HCl. So you want to multiply this by the molar ratio. You want to cancel the moles of HCl and convert to the moles of H2 on the top. And what you're going to be doing is you're going to be using the coefficients. So for the molar ratio, use the coefficients. So what I'd like you to do is see if you can solve this problem by doing the molar ratio using the coefficients of hydrochloric acid to hydrogen, and see if you can go ahead and solve this. I'd like you to pause the video now and attempt this problem, and then come back and then look at the solution. Okay, hopefully you've done this problem and you've come back, and we're going to be multiplying by, again, the molar ratio. And this is going to be a one-step problem because we're just going from moles to moles. So I have my moles of hydrochloric acid. That's what I want to cancel. So I'm going to cancel on the bottom the moles of hydrochloric acid. We're going to be converting into moles of hydrogen. So what you're canceling always goes on the bottom, what you're converting into goes on the top. But now we need to use the coefficients. What's the ratio? Here's the hydrochloric acid, here's the hydrogen. So the moles of hydrochloric acid is going to be 2. For every 2 moles of this, it's going to produce 1 mole of hydrogen. Again, the coefficient in front is going to be 1. And so what we're going to do is you'll use your calculator, and you'll take 1.4, multiply by 1, which is really just not changing the value, and dividing by 2. So 1.4 divided by 2. This will give me 0.70 moles. The moles of HCl cancel, the moles of HCl cancel, and I'm left with moles of H2. So you should always end up with what you're being asked by the question. What's the moles of product? Here's the moles of product right here. Given the moles of reactant, here's the moles of the reactant. Using the molar ratio, so again, this is the molar ratio, and the 1 comes from the coefficient right here, and the 2 comes from the coefficient right there. Next problem is going to be, if given grams of one reactant, trying to find the grams of product. Use the molar mass of the reactant, the molar ratio, then the molar mass of the product. So if given the grams of one reactant, trying to find the grams of product. So going from the grams to grams. Okay, this is a grams to moles to moles to grams. So we're going to have to use the molar mass of the reactant. Then we're going to have to use the molar ratio as we did here with the coefficients. And we're going to have to use the molar mass of the product as well. So the question is going to be, what is the number of grams of hydrogen gas? So we're trying to find the number of grams of this. And we're going to be starting off with 10 grams of magnesium. So if given 10 grams of magnesium, how many grams of hydrogen would be produced? So we'll always start with what we've been given, and it's going to be 10.0 grams of magnesium. This is going to require 3 steps: grams to moles to moles to grams. This is going to be the molar mass of magnesium. We're going to convert the grams into moles. Then we're going to multiply by the molar volume. Again, using the coefficients in the problem. So from grams of magnesium to moles of magnesium, from moles of magnesium to moles of hydrogen, from moles of hydrogen to grams of hydrogen. And for the last step, you'll be using the molar mass. So for this, you're using the molar mass of the hydrogen. For here, of the magnesium. The end, you'll be using the molar mass of the hydrogen. And again, you'll need to use the steps for calculating the molar mass by doing the sum of the atomic masses. So what I'd like you to do is to attempt this problem, converting into moles of magnesium to moles of hydrogen to grams of hydrogen, and we'll see what you get. So please go ahead and pause the video now and come back when you've completed the problem. Okay, so we're going to see if you guys got this right. So our first step is we're going to be converting from the grams of magnesium to the moles of magnesium. Writing in units is very, very important because we want to make sure that we're canceling the correct things here. 1 mole of magnesium weighs, if you go to the periodic table, you'll see that it weighs 24.3 grams. Now, magnesium is a single element, meaning that we don't have to add any of the atomic masses because we only have 1 atom, 1 element. This will cancel out the grams of magnesium and the grams of magnesium. We now have moles of magnesium. So now we're into the molar volume using the coefficients just as we did with the previous problem. We want to cancel the moles of magnesium and convert to the moles of hydrogen. We're going to use the coefficients, and the coefficient in front of the hydrogen is going to be a 1. Coefficient in front of the magnesium is also going to be a 1. So we've just now converted to moles of magnesium, and the last step is going to be using the molar mass of hydrogen. The moles of hydrogen to the grams of hydrogen. 1 mole of hydrogen weighs, how much does it weigh? For this, again, you list the elements that you have present. We only have 1, and it's hydrogen. And you then list the number that you have. We have 2 hydrogens, and the mass of each hydrogen, if you look at the periodic table, is 1.0. So the molar mass of H2 is going to be the sum of the masses of each H, so it's going to be 2.0 grams. So for this, the moles of hydrogen cancel and the moles of hydrogen cancel. We're going to multiply everything on the top Okay, but we're really, again, when you multiply by 1, it doesn't change the value. So we're really multiplying this number times this number divided by this number. On your calculators, 10 times 2 divided by 24.3 will give you 0.823 grams of hydrogen. Going from grams to moles to grams. Okay, so on to the last page, we have 3 more problems to complete. And this one is going to be to find the limiting reactant when given grams. We're going to use grams, moles to grams to determine the grams of the product. Okay, so this actually should be the product right here. Okay, so let's say that we have been given 30 grams of magnesium, 30.0 grams of magnesium. We also have 40.0 grams of hydrochloric acid. What is the limiting reactant? Actually, so that actually should be reactant, my bad. So we're comparing the 2 reactants to see which one is limiting. If you remember the example of the ham sandwich, when you have 8 slices of bread and you have 3 slices of meat, you can only make 3 sandwiches because what's limiting you from making more is the amount or number of slices of ham. So we need to convert grams to moles to grams to our end to see what's needed of the other thing. So let's go ahead and start with this one here, the 30 grams. So here's an if. If I've been given 30.0 grams of magnesium, I want to see how many grams of hydrochloric acid am I going to need to react with that 30 grams. So this is going to give me the exact amount that I'm going to need. So this is going to be a grams, moles to grams. So it's going to be a 3-step process. Okay, and you're going to be using, again, the molar mass. That's my little girl. This is going to be using the molar volume, and again, the molar mass. You're going to convert from grams of magnesium to moles of magnesium, then moles of magnesium to moles of hydrochloric acid, then moles of hydrochloric acid to grams of hydrochloric acid. So for this, we're using grams, moles to grams, and we're comparing the reactant number 1, which is the magnesium, to the reactant number 2, which is the hydrochloric acid. Calculating the molar mass for the magnesium is not going to be difficult. Calculating the molar mass for the hydrochloric acid is going to be a little bit more complicated. Use your periodic table. Please go ahead and attempt this problem and come back and complete it after you've attempted this. Okay, hopefully you've attempted this, and we need to convert the grams of magnesium into the moles of magnesium. From the previous page, 1 mole of magnesium weighs 24.3 grams. So I've converted grams of magnesium now into moles of magnesium by using the molar mass of my compound, which is magnesium. Now I'm going to be converting from moles of magnesium, canceling my moles of magnesium, to my other reactant, which is the moles of hydrochloric acid. Again, we use the coefficients. What's the coefficients for the hydrochloric acid? It's 2. What's the coefficient for the magnesium? It's going to be 1. So for every 2 moles of hydrochloric acid, I'll need 1 mole of the magnesium. Or for every one of these, I'll need 2 of these. So now I've canceled my moles of magnesium, and I now want to convert from my moles of HCl to grams of HCl. This is the molar mass. 1 mole of this substance weighs, well, we have to now list my elements. I have hydrogen and I have chlorine. You look at the subscripts, which is a 1 and a 1. I have 1 atom of each. Then you multiply this by the mass of each of those. Hydrogen weighs 1.0. Chlorine weighs 35.5 grams. So this is 1.0 and 35.5. Remember, the molar mass is the sum of the atomic masses. Each hydrogen weighs 1, each chlorine weighs 35.5. I add those together, this will give me 36.5. So if it was another compound like the magnesium chloride, which we'll get in the next one, you'll be using 1 magnesium and 2 chlorines. So we'll get to that in the next problem as well. So this weighs 36.5 grams, and I'm going to multiply everything on the top and divide it by the bottom. So if you multiply the 30 times the 2 times 36.5 divided by 24.3. Don't need to use any parentheses because there's only one thing that's going to be in the bottom. This will give me 90.1 grams. So 90.1 grams is needed of HCl. Okay, so now, how many do I have? I've only been given 40. So do I have more than I need, or do I need more than I have? I need 90.1. I only have 40. So I need more than I have. What does that mean? Does that make this, if I need more than I have, is this limited or is this going to be excess? Well, if you have more than you need, that's going to be excess. If you need more than you have, that means this is going to be limited. HCl is limited. That's how you find the limiting reactant. So now, calculate, the last problem of this is calculate the grams of product by using the grams of limiting reactant. Well, we just found out that the HCl is limiting. So I'm going to be using this 40 grams of HCl. And my product that I want to go for this time is going to be my magnesium chloride. So given the number of grams of this, what's the theoretical number of grams that I should get from this reaction? Here's going to be another grams to moles to moles to grams, but it's going to be from now hydrochloric acid to magnesium chloride. It's going to be 3 steps. You're going to have your grams of hydrochloric acid to moles of hydrochloric acid, moles of hydrochloric acid to moles of magnesium chloride using the molar ratio, moles of magnesium chloride to grams of magnesium chloride, which means you have to get the molar mass of magnesium chloride. So here's the molar mass, molar volume, and the molar mass again. What I'd like you to do is pause and see if you can do all the calculations from grams to moles to grams using the molar mass of hydrochloric acid, the molar ratio, that should be molar ratio up there as well, and the molar mass. Okay, hopefully you've attempted this problem, and we're going to see if you got it right. So here's the molar mass of hydrochloric acid. So the grams of HCl to the moles of HCl. 1 mole of HCl weighs, we've already done this over here, and that's 36.5 grams. We now canceled the grams of HCl. Now we have moles of HCl. So we want to cancel the moles of HCl of my reactant and convert to the moles of MgCl2 using again the molar ratio. How many moles of MgCl2 do I have? There's 1. How many moles of HCl do I have? 2. So I'll cancel the moles of HCl, cancel the moles of HCl, and I'll have the moles of MgCl2 going to be converting to grams of MgCl2. 1 mole of MgCl2 weighs, well, this is what we have to figure out now. So I have my elements, magnesium and chlorine. How many magnesiums do I have? I have 1. How many chlorines do I have? I have 2. Each magnesium weighs 24.3. Each chlorine weighs 35.5. This will give me a mass of 24.3 for the magnesium, and if I multiply this by 2, this will give me 71.0. So MgCl2, the magnesium weighs 24.3, the chlorine weighs 71.0. When I add those together, this will give me 95.3 grams. Plug this number up here, 95.3 grams. Moles of magnesium converted to grams of magnesium. Multiply everything on the top. These are 1s, so we're going to be multiplying this by this. Divide everything on the bottom. However, notice we have 2 things on the bottom, so this could be very tricky. So on your calculators, you're going to have to divide in parentheses, or you're going to have to divide twice. So on your calculators, you'll have 40.0 times 95.3 divided by parentheses 36.5 times 2 close parentheses. I did it wrong. There we go. You should get 52.2 grams of MgCl2 based upon 40 grams of hydrochloric acid being the limiting. That means we have an excess amount of magnesium. So this is the 100% theoretical yield. This is what we would expect to get. So the last problem is going to be calculate the percent yield. So if we were going back to the beginning over here, and if we were given 30.0 grams of magnesium and 40.0 grams of HCl, okay, let's say from this we actually got, as a product, we got 41.0 grams of MgCl2. Let's say we did this in the laboratory. Okay, so we reacted these two, the hydrogen gas went into the air, and we now have 41.0 grams of magnesium chloride. We would expect by this to get 52.2 grams. We want to calculate the percent yield. How close do we get to our 52.2? Remember, our percent yield is really, it's the part divided by the total. It's what you got over expected. So again, the percent yield is equal to what you got over what you expected to get. It's what you got in the laboratory, the experimental, divided by the theoretical, or what you should have gotten. Then we multiply this by 100%. So we got 41.0 grams. We should have gotten 52.2 grams. We multiply this by 100%. We get 41 divided by 52.2 times 100. This gives us 78.5%. that concludes the second part of our review for Chapter 12. Hopefully you gave yourself a chance to try each of those problems. It's really important that you struggle through them. If you're finished with this study guide right now, I would like you to work on completing and doing the problems for Chapter 12 homework. We'll see you guys on Tuesday, and we'll discuss what we're doing for the rest of the week then.